Hello, my name is Tristen, and today I'm going to be talking about algae as a biofuel. For a short rundown, what I'm going to be discussing in this presentation, first we're going to start with the introduction of what algae is as a biofuel, then how it's cultivated, and then how it's reduced to a fuel. Then we're going to go over the development status, the effects on the carbon footprint, and economic impacts. Finally, we're going to end it with communication efforts and the current state and my plan of action. To start, what are algal biofuels? Algal biofuel refers to the use of algae, specifically microalgae or macroalgae, also known as seaweed, as a source of renewable energy. These algae can be cultivated and processed to produce biofuels. The key to algae's potential as a renewable fuel source lies in the way they store energy. That's because some strains of algae store energy in the form of natural oils. Once you extract that oil, you then have the raw materials to make fuel for cars, trucks, trains, and planes. Next, the cultivation of algae. There are two types of systems that algae is cultivated in: closed systems and open pond systems. In closed systems, also known as photobioreactors, algae is grown and cultivated. These systems provide a controlled environment for algae cultivation, which provides benefits such as minimized contamination, increased productivity, and year-round operation, although these methods are usually more costly. In open pond systems, open air facilities are used where algae is cultivated in shallow sunlit ponds or raceways. These systems are much less complex and cost efficient, but do have some downsides. This is a picture showing the two different systems. For fill production, there are 6 steps. The first one is harvesting. This is where algae is harvested from the cultivation system. Next, we move on to dewatering. Usually after harvesting, the algae biomass contains a significant amount of water, which needs to be processed and removed so we can move on to the next step, which is cell disruption. Algae cells are typically surrounded by a rigid cell wall, which must be broken to access the intracellular components, such as lipids. Cell disruption methods, such as mechanical disruption or chemical treatments, are used to break open the cells and release the lipid content. Next, we move on to lipid extraction. This is where the lipids are then extracted so they can be pretty much turned into the energy we need. Next is transesterification. This is a process where the extracted lipids, primarily triglycerides, are converted into biodiesel through a process called, well, transesterification. In this process, the triglycerides react with an alcohol, usually methanol or ethanol, in the presence of a catalyst to produce biodiesel and glycerol as a byproduct. Lastly, the energy is the fuel is purified and refined. This is a visual representation of the process. Next, we move on to the development status of algae as biofuel. Currently, algae as biofuel is really in its research stage. Algal biofuel has shown considerable promise as a renewable and sustainable alternative to conventional fossil fuels. However, its development status is still evolving, and several key factors influence its progress. While extensive research has been conducted proving how algae is an optimal energy source, implementing the research is very costly. Other issues, such as producing energy on a large scale, are also trying to be solved before it becomes widely available. The impacts of of algae biofuel on carbon footprints. It is clear that any source of energy other than fossil fuels is more sustainable. Algae biofuel has the potential to significantly reduce carbon emissions and mitigate the carbon footprint compared to conventional fossil fuels. Algae absorb carbon dioxide during photosynthesis, effectively sequestering carbon from the atmosphere. When algae are cultivated for biofuel production, the captured carbon remains stored within the biomass. Additionally, when algae biofuels are processed for energy, the CO2 release is roughly equivalent to the amount previously absorbed during cultivation, creating a closed carbon cycle. Next, we move on to the economic impacts of algae as biofuel. As mentioned previously, using algae as a biofuel is a very costly concept. Challenges such as high initial capital investments, energy-intensive processes, and uncertainties in market demand can further contribute to the economic cost of using algae as biofuel. Additionally, the scale of production plays a significant role, with larger scale operations often benefiting from the economies of scale, while smaller scale operations may face higher per unit cost. On the other hand, algal biofuels offer economic benefits by providing an alternative to fossil fuels, creating jobs, stimulating rural development, generating value-added co-products, promoting innovation, and attracting policy support. While economic challenges exist, ongoing efforts to reduce production costs, enhance efficiency, and address market barriers aim to improve the economic viability of algal biofuel production. Next, we move on to current communication efforts. When discussing any type of biofuel, communication is super important. Efforts to communicate the use of algae biofuel to the public involves various strategies aimed at raising awareness, educating stakeholders, and promoting the benefits of algae biofuel as a renewable energy source. Effective communication efforts play a crucial role in building public awareness, acceptance, and support for algae biofuel as a renewable energy source. ExxonMobil is a leading contributor to these efforts, as they have produced many advertisements pertaining to biofuel. The current state and plan and my plan of action. Based on the research done for this project, I conclude that the future of algae as a biofuel is very bright. Not only does it pose great sustainability and economic advantages, but further applications research of algae may be applied in other fields. Overall, the future of algae as a biofuel is characterized by ongoing innovation, sustainability, market expansion, and collaboration. While challenges remain, the continued advancement of algae biofuel technologies hold promises for contributing to more sustainable and resilient energy future. In terms of my plan of action, without the obstacle of funding, a three-step plan of action with the goal of implementing algal biofuel on a large scale would be put in place. The three steps would consist of research and development, which has been and is still ongoing, infrastructure development, which means building the infrastructure needed to produce algal biofuel, and lastly, market development and commercialization. With any plan of action, the last step is always to commercialize it, which especially with a biofuel is important, with any fuel is important. By following this plan of action, various challenges may be overcome, opportunities can be capitalized, and the full potential of algae biofuel as a sustainable and scalable energy solution can be realized. And these are my citations. Thank you.